How's it going, YouTube? Dom here. In this video, we're going to do number 432, all-in-one data structure. So, design a data structure to store the strings counts with the ability to return the strings with minimum and maximum counts. Implement the all-in-one class. All-one initializes the object of the data structure. Inc string key increments the count of the string key by 1. If key does not exist in the data structure, insert it with the count 1. Decrement decrements the count of the string key by 1. If the count's key is 0 after the decrement, remove it from the data structure. It is guaranteed that the key exists in the data structure before the decrement. GetMaxKey returns one of the keys with the maximal count. If no element exists, return an empty string. GetMinKey returns one of the keys with the minimum count. If no element exists, return an empty string. Right? So, you can see here an explanation here. Here we're just launching the all-one class. Here we're increment, we're putting the hello into the data structure here. So the question you might be asking is, what's going on right now? Well, the way you want to think of it is you want to think of it like a doubly linked list, except that's not what I wanted. So what we want to think of is, instead of having your standard doubly linked list nodes, I like to think of it like a bucket, right? So you have a couple of buckets, or it can be like a basketball net, and you're trying to put values into the basketball net, right? And obviously you have these two doubly linked lists here, right? Let's draw her out. And just a side note here, this is a pretty hard question for, so if you ever get in an interview, the chances are they want to know what your thought process is, and you're probably not going to get around to implementing the entirety of the code. So as long as you can understand the concept and what's going on behind this problem, you're going to get good marks on this particular problem, right? Because the thing is, it took me like 45 minutes to really code up the solution the first time. So if you don't get it within the 35 minutes, it's not a big deal. You really want to showcase your thought process behind it, just like I'm doing with this video here, right? So what you want to think about is, let's just say that I represent hello as H, right? The reason why I'm doing that is just because it's easier to draw. And I like to think of it like a basketball, and I'm putting this basketball over here, right? That's increment. And then when I call increment again, what's happening here is I'm removing the basketball from this one. So I'm gonna go here. I remove the basketball with H, and I put it into the next one, right? Alright, all one, get max key. What we're doing here is we're getting the max key, and the max key here is, remember, another thing that we need to do is we need to keep track of the max key. So the max key in this case is going to be the head node here, right? Because think about it, like, we increment the count of the string by 1. If the key does not exist in the data structure, insert it with a count of 1. So as a clarifying question, if I was in an interview setting, what I typically ask is, you know, how many buckets here are we actually starting off with, right? So for this particular video, I'm going to be under the assumption that, you know, you have no buckets, and then you're going to add buckets as you go along, right? So the max key is going to be equal to the head, and then you have the tail too, right? And then get the min key, which is return hello, because obviously you only have this one here. All right. Yep. So that's basically what's going on here. And then obviously you're gonna add Leet to the and have a basketball called Leet. right? And then again, you're going to put the Leet basketball into the bucket here. Very ugly bucket, but bear with me. So you're going to put the Leet here, and then max key is still over here. We still see the max key inside of our bucket here. And we also have the min key, which is Leet here, right? Alright, so now that we have a conceptual understanding of the problem, what are some factors that we need to consider? Well, we need to keep track of the string key, right? So what I'm going to do is I'm going to call something called key counter, and I'm going to initiate it as a hash map to keep track of what the keys are, what our current keys actually are, right? Because we're going to increment and we're going to decrement, and we want to know, like for this one, if the key is 0 after the decrement, we want to remove it from the data structure. I also want to keep a count of how many buckets I have here, right? So that's another thing that's going to also do with a hash map. So keep track of the buckets. I'm going to call it, we'll call it buckets. Alright, so now that we have a relatively conceptual understanding of the problem, how do we actually code it up? Well, before we get to the coding the solution, what we need to do is we need to set up this doubly linked list, right? So what we're going to do is we're going to have one for the node, so it's going to be the actual bucket here, and then one for the doubly linked list, right? It's going to be these values over here, right? So instead, to make our code a little bit more clean, what we're going to do is we're going to create two classes, one for the node and one for the doubly linked list, right? So let's do that. So class node object, right? I'm going to expand this a little bit more. We're done with the explanation, so no need to use this no more. So class node, so def init self, and then I'm going to copy paste this because I'm lazy. Double linked list. Alright, so how do we do this? Well, the first thing I want to do is I want to create an empty list that I'm going to call self.list. Oops, that's not a hash map. Alright, and we're going to also have our heads and our previous. Self.prev, well, we're going to have next. And we're initially going to set this to none and none, right? So what functions do we need to have in our node? Well, we want to find a way to add the key, aka our basketball here. So we want a function to add key, right? And obviously it's going to take in the self and the key, right? And it's simply going to be self.add self.list.add key, right? Then the next thing that we're going to do is we're going to find a way to remove the key. So def remove key self key, and it's going to be the same concept. So self.list.remove key, right? So let's see. Another thing that we're going to do is we need to find a way to retrieve the value of the key. So we're going to call that get any key. We're going to pass in self. So what we want to do here is if our list contains values, you want to find a way to get this this key. So basically we're there's a basketball currently inside of our nets here, right? And we want to take out the basketball and return its value, aka the string, right? So if self.list, what we're going to do is result is equal to self.list.pop, right? And then we're going to go self.add key, because all we want to do is you want to retrieve the value, and then we want to put it back inside of our net here, right? Think of it like you're putting your hand in a bunch of marbles. You want to see what the marbles are, and then you're putting it back, right? Alright, and we're going to return the result here. And if it's not in the list, all we're going to do is we're going to return none, or null. In Python, it's going to be null, or none rather. So that's why we're doing that. Another thing is we want to count exactly how many values are inside of our node. So to do this, very simple here. All we're going to do is we're going to return the length of self.list, so the length of however many values are inside of our list here, def. And then lastly, we want to check if it's empty. The reason for this is we're going to eventually use it later. So is empty. So we're going to return true if the length of the list is equal to 0. Right? So now let's take care of our doubly linked list values. So if you guys don't know what a doubly linked list is, it's going to be something like this. So it's very similar to a regular linked list, except it's going back and forth. Makes it very easy to add values, remove values, and stuff like that. So in order to initiate it, we need to initiate the head and the tail. Self.head, self.tail is equal to node and node. So for example here, you would call this like self.tail and self.head, right? So what we need to do now is we need to set the pointers. So self.head.next, self.tail.prev is equal to self.tail, self.head. So for this one, we're basically setting our so we're setting self.head.next is equal to self.tail. So tail is going to be over here, and head's going to be over here. So self.head.next is equal to self.tail, self.head, self.tail.prev is equal to self.head, right? And what are some functions that we need? Well, we want to find a way to insert after, because if we look at the requirements here, we can see that we need to increment and decrement it. So it makes sense that we need to insert after and insert before, right? So let's do that. So insert after self, and we're going to call it node X, right? And I'll explain that pictorially in a second. So we have our node, and we have our temp is equal to the node, and we have x.next, right? Then we have x.next node.previous is equal to node and x, right? Then we have node.next temp.prev is equal to temp and node. So here we're going to use the same example here. We're inserting before, so we're assuming that we have a node x here. We're using x.next going over here is equal to the node and we have node.prev is equal to x, right? That's kind of how it works there. And lastly, we're going to return node. All right, so we also need to insert before, same concept here, self x, and it makes sense for us to reuse the values that we already had there because we already made it, except this time we're going to use x.prev. So assuming x is over here, we're going to add a node before, just like that. Kind of out of space here, but you get the point. So we're going to return insert after, and then it's self, or not self, x.previous, right? So what other functions do we need? Well, we need a way to remove the node, right? Because if we look at our all-in-one data structure here, we can see that, you know, we need to remove it from the data structure if the count of the key is 0. So let's do that. So def remove self x, and we're going to set the previous node to equal to x.previous. So assuming a node x, right, we set that to the previous node, and then previous node dot next x.next.previous is equal to x.next previous node, right? So assuming that this is the x here, basically removing the nodes here, and we're setting this over here, right? Kind of messy, but let me know in the comments if you have any questions regarding that. You can definitely clear that up if that's not clear, right? So another thing that we need here, see if I got everything. Yeah, that's it for remove. So another thing is we need to find where the head node is and where the tail node is. In order to do that, I'm gonna call a function called getHead, get your mind out of the gutter. So all we do is return self.head.next. And we do the same for getTail, self. And to do that, we get self.tail.previous, right? And then also, one thing I forgot to mention here is we want to use a dummy node. And the reason for this is it simply makes our calculations a lot easier, especially when you're adding nodes or moving nodes. When it comes to a doubly linked list, it makes sense for us to do a dummy head and a dummy tail, right? So we want to find a way to get our dummy head. So I'm going to code that up and then I'm going to explain a little bit more. So get dummy head self, and to do that, all we simply do is we are going to return self.head, and we do the same thing for get dummy tail self, return self.tail, right? So here we see here that, let's just say that this one was our dummy dot c. Delete this. I'm gonna make it a little bit more clean here. So we have here a linked list value. Then this one's this way, this one's that way. All right. This one's here, this one's here. And there we go. So basically what's happening here is we have a dummy head in which we call self.head. and that's going to be over here. Or no, my bad. This is actually going to be over here. So this is our, I'll call it DH, and this is going to be our DT, right? And this is going to be the head, and this is going to be the tail. This is going to make our calculations a lot easier, especially when it comes to the code later on. So I'm going to keep this image here, and it's going to become a lot clearer in a little bit when we get to the all-in-one class, right? So what we're going to do now is let's work on our all-in-one class here. So here now what we need to do is we need to work on our all-in-one class. So let's start with the init first. So our init, we're going to set the doubly linked list, and we're also going to initiate our key counter, right? So our doubly linked list is simply going to be double linked list as seen above over here, right? And we're also going to have so key counter, we can either do a hash map like this. I'm going to set the default dictionary, right? And obviously the default dictionary type is going to be an integer, right? And obviously I need to add my default dict. So from collections, import default dict. All right, go back down here. So what we need to do now is we need to set our node frequency, also known as buckets. I'm actually going to call it, should I call it buckets or node frequency? I'm going to call it node frequency. And that's going to be a hash map from 0 to here's when the kind of linked list values, the dummy head comes into play, right? Because we want to iterate, we want to have a node frequency depending on how many nodes that we have from whatever our tail is to our head, and including our dummy head, right? So we're going to initiate the node frequency as 0 to self.dll.get dummy head. There we go. So now what I want to do is I want to call a helper function that helps us remove the key from the previous frequency node. Because if you recall, what we did before is we wanted to, let's just say that we had this here, like the basketball inside of the net. We want to find a way to take out the basketball, right? Because we can't have two basketballs of the same value at the same place. We need to clear this in order for us to make room for more strings in that particular value. So it makes sense for us to remove this from our basketball net, right? So let's do that. I'm gonna call it remove key from previous frequency node, and I'm gonna call this self. I'm gonna pass in self previous frequency and key, right? So we're gonna represent the node to be the one that we actually take out, the basketball, right? So it's going to be self.node frequency. Can pass in previous frequency, because you think about it, let's just say that the current frequency was here. So current frequency, that means our previous frequency would be over here, right? All right, so let's make this a little bit more pretty here. So the next thing we want to do is we want to remove the key, right? Because this is calling node frequency. Yeah, remove key. We're gonna remove the key as we see over here, right? Because remember, this is part of the node right now. So the next thing we need to do, we want to check if node.isEmpty. What we want to do is we want to remove this value from the node here, right? So DLL remove key, which is evident over here, right? We're going to especially use it in the decrement string key. So let's see. And the next thing we're going to do is we're going to pop the node frequency, or pop the previous frequency rather. What am I doing? Pop previous frequency, right? And lastly, we're going to return. Now let's take care of the increment function. So if we take a look here, we can see that it increments the count of the string's key by 1. If the key does not exist in the data structure, insert it with the count 1. So basically what it's saying is, let's just say that our basketball was here. If we wanted to increment it, we're taking out this one, we're removing this from our bucket, we're adding a new bucket here, right? With our usual doubly linked list properties. So just like this and like this, right? And then we're inserting it into the new bucket here. That's exactly what we're trying to do here. So what we want to do first is, remember, we made a key counter here. So we want to first start by incrementing that key counter by 1. Right? Now let's set 2 variables here. Current frequency, previous frequency. Is equal to self.key count key. So basically this is so the key counter is keeping track of exactly where where the ball is inside of the net. So here we would have our current frequency, and here we have our previous frequency, right? Self.key counter key -1. Oops. So if the current frequency is not in self.node frequency, this basically is saying that if the node does not exist inside of our current basketball nets, you want to add one to it, right? So what we're going to do is we're going to self.node frequency current frequency equals self.doubly linked list, and then we want to insert after, we want to insert the previous frequency in there. Right? Now what we need to do is we need to add the key. Add key key. So we add the key as listed above, add the ball to our basketball net, basically, right? And lastly, what we need to do is we need to remove the basketball from the previous net, right? So we only can do that if previous frequency is greater than 0. We're going to self.remove key from previous frequency node, previous frequency key. Because think about it. If you have one basketball, right, and you don't really need to remove anything, so we're just checking here to see that if previous frequency is greater than 0, then we're going to remove the basketball from the previous net, right? So now let's work on the decrement function. So I'm lazy, so I'm going to copy and paste this, except I'm going to decrement this by 1. And this one's going to be +1. Because in this particular case, what we're doing here is if I have, so basically I will have, say, a basketball in here. I want to put this inside of this basketball. So that's exactly why I'm doing this particular line right here, right? So we want to also check if this key counter is equal to 0. What we want to do is, if we look at the function here, if the count of the key is 0 after the decrement, remove it from the data structure, right? So we want to remove the key from the data structure, right? So self.keyCounter.pop, we're going to pop the key. So we're removing it from the data structure here, right? So what if current frequency is not equal to 0? So we want to check if the current frequency is not in the node frequency, right? We want to see if it's not currently in the basketball net, then we want to put it inside of the basketball net, right? So self.node frequency current frequency is equal to self.doubly linked list insert before. So we're inserting a new node beforehand unless it's at 0, right? And we're going to pass in our, we're going to pass in self.node frequency previous frequency, right? And then lastly, I'm a little bit lazy today, so self.node frequency at key current frequency is equal to 0. Made a little typo here. If current frequency not in self.node. Load suggestions, please. Frequency. And then lastly, we're going to copy paste this. And then we want to remove. Alright, you don't want to play nice with me, autocomplete, so I'm just going to copy paste this. So you move the previous frequency, that's in previous frequency, and the key. So the last area of business here is to get the max key. So in order to get the max key, we take a look to see where the tail is, right? And that's going to be our maximum value, right? I wrote this backwards, so apologies for the mistake here, right? So this is actually going to be tail and head, dummy head, and dummy tail, right? So we're going to return self.doubly linked list get tail get any key. We're looking for the basketball here. If self.doubly linked list get tail count. So here we see here that we want to return one of the keys with the maximum count. If no element exists, then we're just going to return an empty string, else empty string. Then again, I'm going to copy paste this because it's kind of the same concept here, except we're going to get the head here. Oops. And that should work, given that I didn't make any mistakes, which there's a collections, default dict, int is not defined. Whoops, my Swift is coming out here. List object does not have add. Huh. Interesting. Oh, what am I doing? I forgot. This is a set. So, prev node does not have an attribute prev. Forgot some return statements here. Nope, that didn't fix it. Alright, so my recording cut out by accident here, but I noticed a couple typos here. So I put this as a key, should have been the node. And this one is actually not a squared bracket, it's actually a curly bracket. So as you can see here, it is accepted. If I click accept here, you see that it's accepted. So this is a O of 1, obviously, solution with an O of K memory complexity, depending how many times we're shooting the basketball per se. So this was a long question, and this was a very gnarly question. As you can see here, I'm pretty much at like 45 minutes, and realistically, if you guys get this as an interview problem, you're not going to finish in the 45 minutes. They just want to see your thought process and how you process a problem like this. So don't worry too much if you don't really understand this problem. I'm still trying to wrap my head around it, but this is the basic concept that you need to know. So this video was helpful in any way. Don't forget to hit like, comment, subscribe. Stay tuned for other programming tutorials, entrepreneurial ventures, and stuff like that. Leave me a comment, tell me what you thought about it, and I'll see you next time.